My parents warned me that if I didn't take math seriously, I would never graduate high school. So they made my brother, who excelled in math, tutor me. I remember asking him, "Why do we have to do long division? Is there a shorter way?" He said, "You don't ask why in math. You just follow the rules, and then you'll get a high grade." Hmm, math practice was either so repetitive or had too many steps. It almost always felt like I was lost in a maze. My mind was spinning all the time. It felt so dizzy. I couldn't remember the next step. I was not allowed to ask why, like carry over or borrow in subtraction. When I missed a step, I felt like a robot. My brain automatically shut down. One fine morning, I woke up feeling liberated. I just had to say to the world, "Gosh, I'm not good in math." Years later, preparing a pitch deck, I learned about spreadsheets. Gosh, it was a eureka moment. Math suddenly made sense. I discovered math is about the bottom line. Of course, we all know math is more than just about spreadsheets. Hi, I'm Gigi Karunungan. This is a documentary of my study on reinventing math with stories, games, and creative activities with two teachers and 5 to 7-year-old children in an after school program in Silicon Valley. In the world of math, each of us can either be like me or my brother. Even if I tried, learning mechanically without understanding just did not create the spark for math. Math is a fragile theme that touches on many sad and traumatic childhood experiences, with not getting as high grades as one would hope, just like my own. It made me feel like I was born with less opportunities to succeed. I realized I was not alone struggling with math education. In fact, my experience was related to the decades long challenges that the United States is dealing with in raising students' proficiency levels. By 2019, among fourth graders, only 41% of students met the expected math proficiency benchmarks. It gets worse. In the higher grades, eighth graders performed at 34% and 12th graders at 24%. Math is one of the more contentious topics in K 12. In this regard, I invited professors, education leaders, parents, and teachers to share their views on this study, to expand and deepen perspectives, theories, and insights on the challenges of today's math education, as well as on the exploratory study on math stories.
Unfortunately, we use math as a gatekeeper. There is a concept out there that only smart people, however you define smart, which is already dangerous. What is smart? And still, there's the myth out there that girls cannot do math and boys can do math. So, this is one of those, I call them myths.
As teachers, especially in the elementary level, it's predominantly women. And if we grew up with this message that math is for boys, that you're born with it or without it, then we have many of us, including myself, when I was in the classroom, not really confident with teaching math or even adequately prepared to teach math concepts and skills beyond the repetition and memorization or the curriculum.
If children are math anxious and math avoidant, and they learn to do that at an early age, and they see the math that's taught in some classrooms, I won't say all classrooms, but the math is it's taught in many classrooms, they don't learn that mathematics is problem solving. They learn that mathematics is putting numbers together and doing something with them. But why you're doing that is because the teacher asked you to, not because there were real problems to be solved. That's maybe an extreme position, but I do think it still exists.
We tend to teach kids who come in less prepared mathematically to do rote calculation, right? We tend to be much more, it's about teaching discrete skills as opposed to teaching children to be mathematicians, right? Like our, and then we're not thinking about how do we get them to think about the concept of addition What is addition? It's taking discrete things and putting them together. And like, how can they apply that to the real world?
Every method used in teaching math reflects a worldview on education. A belief or philosophy about education determines the type of math education experienced. Likewise, philosophical views about learning influence the different ways that math is taught and how pedagogy impacts the learner's interest and growth. There are two major worldviews in K-12 education: compliance, memorize, high test scores, learn from the teacher and textbooks, nurture potential, creativity, and curiosity, the capacity to become or to develop into someone in the future. Don't question, study hard. Education is difficult and learning is not fun. Question, figure it out. Knowledge is a set of fixed ideas you need to know to succeed in the system. Develop the ability to discover, analyze, problem solve, and communicate. Explore, understand, and find solutions. Be a follower or get in trouble. Be a problem solver, solve troubles. To learn, ask what, where, and when. To learn, ask why, how, and what if. Questions determine how children learn to think. The education system defines the individual. Students adjust to the system. Every individual is unique in abilities and passions, values students with unique qualities and backgrounds, and grows their potential. One size fits all. Students sit behind their desks, listen, and behave. Differentiated. Lessons are designed to connect with every student. Learning is active and social. Industrial age, when people learn how to work with machines. Age of artificial intelligence, when machines learn how to work with people. Manufacturing economy, factories fuel the economy. Design economy, innovative ideas transform the way people live and work. This is the past. This is the present and future. The behaviorist philosophy provides small, progressive sequences of tasks, such as guided practice, skill and drill, and regular testing. Students are rewarded for obedience to rules and outstanding memory skills. The constructivist philosophy: build from the learner's prior knowledge and engage students in projects that involve meaning-making and knowledge construction. The choice of philosophical framework has a lot at stake with the quality of math education for children in the primary school. By the time students are in the third grade, based on their math learning experiences, most have decided whether they are good or not in math. This study sought to test the efficacy of a math learning solution in the form of math stories based on the scientific understanding of the child as a learner, using the constructivist framework, in the context of a world where digital technologies exist alongside people.
Our job should really be to teach kids mathematicians, to get them into math from day one.
They have to have numbers, processes, procedures, applications to do that. But if the heart is not, number one, persevering in problems and in solving problems, it's not really math.
I train teachers to use math stories at Synapse School, Imagination School, and in schools in Guatemala, and observed how children in the primary grades enjoyed math learning and raised their levels of mathematical understanding with context-based problem solving. When I met Jessica Liu, the illustrator of the books in this study, we had the opportunity to produce math stories that met the needs of today's children.
We are reimagining math learning through stories that are emotionally engaging, with diverse characters from multiple cultures that children can identify with, and with math-oriented narratives set in a town called whatever, where people think they cannot do math. Most importantly, math learning is not about the mechanical and repetitive way of memorizing numbers and math operations. It is all about conceptual understanding, sense-making, reasoning, with math ideas and problem solving.
The math storybooks and activity book, games, and activities are designed as creative and integrative applications of pedagogical theories, which include culturally responsive teaching, constructivism, and cognitive and learning sciences to teach mathematical sense-making and reasoning. But will these solutions work? Exactly the question of this study. Amidst the chaos caused by COVID and Omicron, these teachers agreed to support the research by teaching an after-school program with 2 of the books, games, and activities.
But this is Miss Gigi. Can you wave to Miss Gigi? Say hi, Miss Gigi.
Hi, Miss Gigi.
Miss Gigi has a big question.
I want to know what happens when children learn math with stories.
She wants to know how to make that happen. And I want to know how to make that happen too. So together, we're going to try to figure out part of the answer to that for the next few days, okay?
Okay.
So some of the things that we need to do is making sure, even though it's after school, that you're ready to learn with your body. And we need to put on our attentoscope with our eyes, our ears, our brain, our whole body, and doing our best.
Weren't they? They were really nervous and they really wanted to please me and they wanted to please you.
Welcome to the town of whatever.
Jessica Liu, the illustrator of the book, and I conceptualized the town of whatever and the main characters to reflect and encourage the growing intermixing of cultures from all over the world in the 21st century.
In the town of whatever, many people think they cannot understand math. Is this possible?
No.
It truly is, Gannon.
It truly is.
Would you like to do math with people in this town? Would you like to?
Hello.
So stop. I heard 2 people say different things. Santiago, why would you not want to do math with people in this town?
Because if they don't make it right, then I'll probably have to tell them that answer.
Maybe so. Maybe they're not doing it right and you'd have to give them the answer.
I see one.
Then somebody else said yes. I heard Rebecca. Did I hear you say yes, you'd like to? Why would you like to do math with people in the town?
Because it's so much fun that it could be easy.
All right. Good enough. What do you think?
I
Sebastian?
think not to do math with people.
Why?
I'm a police talk to a stranger.
Oh, okay. Well, that makes sense.
And might steal me.
All right. Gannon, what do you think?
Yes, because you get to learn and you get to know math.
All right. So you get to do more math. Valeria, what would you like?
To help people grow their brains.
Oh, our brains making bigger. Good. Sammy, what do you think? Say it again. What happens in the town when people give up on math and they decide not to solve their problems? What happens?
They won't be smart. They might not know math
Their
in school.
brains will get little and their brains will not grow up. If they don't do math, they won't even know numbers.
Okay, so let's.
And I know
Connecting to students' interests and backgrounds is vital to making math relevant to children. Likened to the main characters, we designed a page where children are invited to draw themselves and their interests.
myself fishing.
Rebecca, what do you?
You're clapping because I said 1 plus 1 equals 2. 2 plus 2 equals 4.
Is that me?
Yeah.
Oh.
Playing video games.
The story is about Maya, a clothes maker, and her friend Ramon, a button maker. Maya sews colorful clothes with distinct designs, and Every shirt and pair of pants she makes is unique for each person. In the town of whatever, people feel special when they wear Maya's clothes.
It was really fun to see the story aspect of it. I like to use stories in math. Having that, like, they can relate to it, and it's easier for them to see. So as like in their mind's eye, if that makes sense. So if they can see it and how that story is playing out, then it was easier for them to like understand what they were doing mathematically.
Today, we're going to make sets. So you're going to tell how you sorted your set of buttons. And you're going to say all of my buttons are in a set because, So you need to make your groups, your sets, and count them and say what their feature is. How are they all the same? So you're going to read the pictures and the numbers, and you need to think to yourself, what am I going to say? How are they all the same? And then you're going to tell your partner how they're the same. Sebastian, look. How is this? What is our set now?
This activity is an open-ended problem created by the teacher from the story. Every student is busy figuring out their solution. The teacher encourages and supports each student. Students learn from peers. The children are thinking, how can I make sense of these buttons and form them into sets?
Yes, and I dropped it and I put here. And
Okay, so what kind of sound is it?
like this.
So what would you call that? Remember our volume?
Low sound.
That's a low sound.
Done.
So that's pitch.
Yeah.
All right. Is there another one
Yeah.
that you dropped?
This.
All right. What is that sound? Is that low or high?
Low.
Oh, so would that go here or would that go there?
Here.
All right. Keep going.
And this is loud. I think.
Oh, road. All right. What are all of those?
White.
They're all white. What would you do with that one?
If you do the front and it changes this.
Does it go in there? Look carefully. What would you think? It's okay to have more than two. Look at Valeria. She's got 3. I'm sure that Rebecca's gonna have like 4. What would you do?
But there's black.
Oh, so you think it's mostly black?
And this is white a little way.
Yeah. Oh, that's kind of really interesting. Do you think you could put them in groups? All right, go for it.
And the same size.
Okay. So last time by color, now you're doing size. Great. Go for it.
Wait, what about the same holes?
Oh. So you see, what do you notice? Some have how many holes? 2 holes.
And then
Some have
4 holes.
Some have 4 holes. Okay. And what about that one?
1 hole.
That's crazy. 1 hole. Let me do that. Okay, go ahead and sort.
This one. Wow.
I'm like,
For the story to capture children's minds, the narrative, the characters, the words, and the design had to connect to their curiosity. The proper balance of math and literary elements can be observed in how children respond to the story. Are they empathizing with the character? Are they following the plot? Are they convinced that by doing the math, they can help the characters? What is fascinating developmentally at this stage is that children respond to real and fictional dilemmas almost like they live in both worlds. The power of fiction is in its ability to add humor, to introduce positive and ideal values, and to imagine possibilities that highlight math concepts. Like Ramon, the button maker, and the tall man's shirt, with a button problem that can make math learning purposeful and accessible. This is the third day of the program for the first book. The children know that they are learning math from a story, and they have been helping the characters overcome their challenges by thinking, doing, and learning about 3 math big ideas. Sets are group of the same types of objects. Equal means the same, and there are many ways to take numbers apart. Today, they will finish reading the story and will learn about equations.
Counts. There are 5 buttonholes without buttons, and Maya does the math. 5 buttons, what's that word? Plus 5 buttonholes equals 10 buttons total. Notice, do you think McCoy is right? Could one shirt have green, circle and green, and one have blue, like square blue ones?
At this moment, the teacher and I looked at each other in amazement at the connection a student was making by touching the button of his shirt as they were reading about equal and not equal number of buttons.
Characters have the ability to tap into students going like, oh, you know, that's me. And it could be because they share the same culture, or they share the same interests, or they are the same race, or they, you know, I mean, there's a whole bunch of different ways that characters could tap into with kids. But I think that they have a great power for helping to contextualize the story for students so that they can figure out what the issues are, what are the problems, what is the puzzle, right? They can really form that sort of, I mean, think about it when we're solving a math problem, when I'm a child, I'm trying to solve a math problem. What's most important is that I can sort of create an image, like almost a movie of the problems that I encounter in my head.
How can anyone be so tall? Ramon wonders. He's never made a set of buttons for someone so tall.
I have to say, seeing like the tall man, like with his buttons missing, I'm like, really, is this really that hard? But it really is. And I thought it was like so silly, but they took it so seriously, didn't they? They're like, oh, we've got to figure this out. So I thought that was pretty ingenious, actually.
This is 10. Yeah. All right. Ramon said something really important. He actually said the word same up here on page 16. Can you find it? Touch the word same.
The context of story is not only the context for understanding, but it's also the context for building understanding, for deepening understanding, and for extending understanding.
Tell me more.
9,
No way. Keiko, write it down.
Wait,
A lot of times to kids, like you either get it right or you get it wrong. Whereas in things like language arts and social studies and such, there's often a lot of different answers. In math, I think that's changing happily. That is changing. We're trying to teach them different strategies. You know, use dot talks and say, you know, what are all the different ways that you can get this many dots? Oh, I could have 2 dots plus 1 dot, or I could have, you know, 1 plus 1 plus 1, or whatever. So sort of teaching them that there are multiple ways that we can get to the same place with math.
I just really feel like they understood what an equation was by the end of those, especially those 2 days that we focused on that aspect of the book. Like, what does it mean to join things? What does it mean that I have an equal sign. What does same mean? And that is actually carried over into like our daytime math, right? Because this was after school. But so I know I come back to it. I teach it heavily at the beginning of the year because for some reason, I don't know why, but a lot of math programs say it's a number sentence. And yeah, that's true. But the mathematician in me is like, it's an equation, right? It's an equation and we need to use the right word. So just understanding what that addition sign means and really what does same mean? And it's a foundation because in first grade later on, right, we talk about balancing equations. Are they the same and different? And it's so hard. It's mind blowing. And I have gray hair because of that topic. It's so hard for little minds. And it was probably hard for my little mind to understand it. So yeah, I think that just the fact that they understood an equation and how they can manipulate it and find all those ranges of what makes 10 is just probably the most impactful thing. I wish they all could have participated in that. Yeah, because all first graders need it. First year.
Is it same or different?
Different. Because
What if I do this?
different.
Does this side is this side the same as this side? Can you sit on your bum?
Yeah.
Did we learn that when we use the addition sign that we're making groups even bigger?
Yeah.
You guys are awesome possum. Next time, we're gonna keep exploring this, okay? Would you please go get
Your
backpacks
That's
line up.
And the power of stories has been recognized for centuries. And learning through stories is really an effective way to give information or to build a connection. And it could definitely be used to make abstract ideas concrete.
So there are many ways to make 10. But if you tell children that there's only one way, it's yes and no, then they don't understand the concept. So what you're doing is truly practicing understanding by design. You design for understanding.
I think they really enjoyed it. They were very accepting and eager to get into this new challenge and this new way of learning. I'll show you the cover. This is Manuel, the table maker. Manuel. Can you all say his name? Manuel. He is the table maker. Let's go ahead and open to page 2. Page 2, I have it up here.
After going through the first math story, it was observable how the students were no longer anxious or trying to please the teachers. They knew what to expect, and they were ready to learn math with the second story.
All right, friends, I'm going to read you the story, and you can follow along with your eyes in your own book. Okay? There will be some times where I stop to ask you questions, and then we will have a game to play at the end.
My children wouldn't go to bed at night until I told them a story. See, they love stories. So why don't we embed what they love? In mathematics, you tell them a story. So the story captures their imagination. The story engages them. And then you introduce the concept. So first, you want to grab their attention. And the story grabs their attention. Then they become engaged in the story, and then they understand the concept.
I remember learning about shapes in kinder and first grade by memorizing the names and numbers of sides of each shape. That's it. The next time we studied shapes in math was when we learned about fractions, and that was not fun at all. A huge cross-cutting concept in science and engineering is shapes make shapes. This is a big idea in biology, chemistry, and all the sciences, as well as the engineering fields. By understanding how this concept translates into mathematics, children can learn to build, communicate, and predict about shapes through visual and mathematical expressions. The triangle is the simplest of all polygons because it only has 3 sides. However, There are different kinds of triangles based on the combinations of the lengths of the three sides.
What else? Oh yeah, that maybe looks like a very good job. One day, a family visits Manuel's studio to buy a dining table. The parents, Lena and Peter, are curious about Manuel's unique tables.
Thousands and thousands of years, culture was handed down, genealogies and so forth, through story. And yet in modern day times, story has diminished emphasis in our lives. I think it's coming back into its own, maybe a little more, but diminishing emphasis in learning other than in literacy and involve them in the process. And I think that's a very important way to not only motivate learners, but also to give them a context for understanding the mathematics and therefore deepen the mathematical understanding that they have.
So before we even draw, let's think. What are some things we do in our free time? Yes. Play, that's a good start. Does anybody play with dolls? Who watches TV on their free time?
Me.
Seeing students draw themselves on this page with very little prodding from the teacher was watching our goal for students to engage as co-participants to the story come to life. Math eventually turns most students away from learning the subject, and when the pedagogy acknowledges each one as a unique and capable individual, intrinsic motivation kicks in.
Right, how they look different. Yes.
Triangles look like sideways. I found the mail. It could be. I found the mail.
No?
I found a nail on the this one.
A nail?
A nail, like
Oh, like a mail, an envelope, like something you put in the mail. Awesome, very cool. It does look like it.
I found scissors.
All right, they are not the same. Manuel directs the family. Here's some string you can use to compare the lengths of the sides. What do you notice about how long the sides of your triangles are? Manuel asks.
The differences between triangles is a critical concept for children to understand. More importantly, knowing how mathematicians use tools to differentiate these three-sided polygons was even more important. The experience in this class prompted the team to add a 2-page spread to heighten the value of learning this concept.
Each person is going to have 18 cards. You can play with a friend or play solo. So what we're going to do is we're going to play by ourselves first. What it's going to look like is there are going to be pictures of something that you see every day, right? These are tortilla chips. Who here likes tortilla chips? I know I do. But you see in the picture a shape is missing. Do you see that shape that's missing? Jamari, do you see that shape that's missing?
That's making me hungry.
Hungry? Me too. At all.
Children cannot master the concepts simply by discussing this within the story. To truly understand the implications of the 3 types of triangles as unique shapes, it was necessary to engage the students in what we call extension activities, such as this card game. The game is played like the memory card game, an already familiar type of game among children. In this way, focus is not on learning the rules of playing, but in using the dynamics of the game to expand the child's sense-making of these 3 triangles and how the different combinations of the lengths of their sides fit into real-world applications. The elements of gamification provide practice opportunities, in this case, analyzing triangle sides and figuring out which ones fit accurately with a real-world object. Playing solo is practice for playing competitively with a partner. Without the story, this card game is simply about memorizing types of triangles. With a story, children have context and connect with the challenges of the characters.
This is the same as this one. If you turn it around straight, like this.
So we're not going to turn the shape around. This is exactly what's missing from a picture. So will this fit in this? No, it won't.
The dynamics of games brings players into a different reality, one that is defined by an artificial set of rules. By agreeing to play by these rules, math learning becomes playful. When we designed the card game, we put careful thought in the way we chose the images. They had to connect with the children's backgrounds and interests, like the most famous triangle in the game, now called tortilla chip. This was a test of whether the memory type game, with 18 cards per child, with the choice of images, levels of complexity, and other design variables, would work. On the first days of the program, girls stayed with girls and boys with boys. The social nature of games, with the rules creating terms of social interactivity, children can play without worrying about gender differences.
So I saw a lot of the kids obviously smiling and very eager with the activities. They were very engaged with all of the different things that they were doing with the game, with the dolphin and the coloring in the books. Like they were really enjoying those parts of it. They're also they were very talkative with one another about what they're reading in the book and how that applies to the activities that they were doing. I want to review with you about the things we learned yesterday. And I want you to look at this purple one, where it has the different triangles and it has the numbers on the triangles. And it says triangle and it has numbers on the little pictures. Hold it up.
My card was like this. I just flipped it over.
Very good. But it's the one with the numbers on the triangles. There we go. Put it to your forehead when you find it. Good. I see you're ready. You're ready. Yep, you got it. You're ready. Yep, you got it. Good, good, good. Take a look at this card.
The teacher is showing and discussing the math big idea cards. Big ideas tend to be difficult to remember. However, when teaching conceptual math, after hands-on activities and reading parts of the story, children need to reflect on their experiences. These are the collectible cards that will help them remember the concepts. The big ideas are formulated from context, using text that can be easily understood.
The red one was telling us about the sides. What is the
corners.
3 corners? So let's look at the red triangle. Can you put your finger on?
What type of words to use for the math books was a decision resulting from extensive studies of how language contributes to children's cognitive growth, as well as my observations of how children express ideas and emotions with words in the classroom and in the real world. It became increasingly clear that at this age, learning math does not and should not require reading skills. Furthermore, I observed how children in different cultures at an early age speak very long words. Keeping to 1 or 2 syllable words will limit their vocabulary. The way we tell the story will make the words make sense to children.
Danielle instructs Kenneth and Jessica to hold 4 strings in a square. Then he tells them to pull back just their right hands. This shape is a rhombus. Can you say rhombus?
Rhombus.
Do you see that shape that they're making with the strings?
Yeah. It's a sideways
That's
square.
the sideways square that we were talking about. So what is it called?
Rhombus.
Rhombus. Kenneth laughs. I see a squashed square. I think it looks like a diamond, says Lena. Do we see Lena on the bottom picturing a diamond? What do her eyes look like?
A diamond.
Diamonds. Now look at this one. Amiel shows them a shape made with 3 triangles. It's called a trapezoid.
This is a trapezoid.
Trapezoid. You can make this with many.
The second half of the book connects triangles with other polygons. At this point, notice how the children are using their new vocabulary to describe the different shapes created with triangles, not from memory, but by looking at the illustrations, analyzing this, and communicating understanding.
You get like to make a rectangle. rectangle. You just need like 2 squares.
And I was so pleased that you didn't level the story with, you didn't limit the vocabulary. Well, I'm sure you did in a sense, but it wasn't really a leveled reader in that you only allowed for so many syllable words and so forth. You allowed for the words that would be meaningful at that particular time. And I could see that was, I was so appreciative that you had not come up with simple substitutes for words that children could understand, particularly if they heard the story, even if they couldn't read it for themselves. So I thought you maintained a quality of vocabulary there that would be very helpful.
The narrative uses figurative language like visual metaphors that are familiar to multicultural children.
In your materials, I see that you are into sense making and reasoning.
Yes.
And I really like that, because I think math without sense making and reasoning is really not math.
I think the activities, they really helped the kiddos visualize the concepts that they were trying to learn. It was great to have the students have those hands-on visuals and hands-on activities as a type of tool to practice and sort of reinforce what the book was trying to teach. Like the coloring of the different animals in the books was good for them to visualize how different sized triangles can fit together and create a different object or a different picture type of thing. So I think that activity really helped them grasp that idea that the triangles, the way their sides are and the way they can connect them, can make so many different things. All right, let's turn the page. Let's turn the page.
We get to take these home.
Yes, after today, you're taking everything home. Can we put that down so we can follow along in the story, please? I love shapes, Manuel smiles, looking at his now even messier studio. Me too, Amiel hands Manuel some shapes. But now it's time to tidy up. How about we write the names of the shapes on the bins?
It is the last day of the program. The students have been asking if they can take the books, the card game, and the activities home. Observe their body language. They are even more connected with the story after they read 2/3 of the narrative, played the triangle game, and worked on their animal mosaic.
Kenneth calls to Jessica. Can you see the triangles on that bridge? But Peter sees something different. Oh no, Peter sighs. There's something going on. Lena worries. The cars have all stopped.
As educators, we talk about wanting our students to continue thinking of what they learned in class after class. This final scene of the story happens outside Manuel's studio on the way home. In a sense, it is parallel to what children may experience after they leave school. The scenario is different from the classroom, and hopefully they, like Jessica and Kenneth, the children in the story, connect what they learned to a different context. This is transfer, the holy grail of math learning.
You are only coloring these 2 parts, friends, these 2 pieces. Color them however you want, or you can use the inside of your book.
Look at mine.
We have a little bit of time, but still. You only need 2 pieces.
Are you doing mine?
Can I see yours?
Yeah.
Let's find our seats and we're... No. Do we think if I continue building like this, will people be safe and driving on my bridge?
No.
No. So we have to think like builders and engineers and connect our triangles together to make the bridge. Okay, I'm going to give you your stickers.
They're connected.
Yeah. Mm-hmm.
Okay, keep going.
At least if they're not drawn.
The program finale. Students and the teacher share their triangle projects. From this experience, we learned that the stickers were not as learning-oriented as we thought. The team redesigned the next version of the project to be non-sticky triangles so students can create multiple designs And if they want the physical equivalent, there is the mobile phone to take the photos.
That's so fun.
Let's give a big thank you to Miss Gigi.
Thank you, Miss Gigi.
The students, they learned that you can build basically anything out of triangles, right? We did a lot of activities of building the animals, or like looking at how triangles were built to make the animals in the book, and then how we made the dolphin out of triangles. So they were really starting to understand the whole concept of how simple and important that shape is. Also with the bridge, how they were able to connect them. They're starting to understand how triangles are all around us. It doesn't matter if our desk is rectangle, we can see triangles within that rectangle. Like we can see triangles all over the place. And I think that is what they were starting to understand.
And so adding stories to math learning, which is typically perceived as a very hard subject, can make learning math skills and concepts easy and natural without losing the cognitive demand that's needed for learning math skills and concepts.
It's definitely different than what has been teaching now. You know, my lessons are typically all about reviewing the concept and how to solve it, and then we'll just practice a bunch of problems, you know, and that helps them learn. But then also this strategy of using a story and tying into what they know and having it connect to them gets their engagement in a different way. So I think it'll be a good mix of doing both. I think that'll be interesting.
The educational system has structured math learning for so many years in discrete activities that in most cases, it is after teachers see how these materials work with children that they understand the power of math stories in developing conceptual math thinking among young learners.
We do have content that we have to teach, and we do have a curriculum that we use for that. But what I do think we lack, the application piece, the transferring piece that we were talking about earlier. Stories, math stories could definitely be integrated to help us then apply the things that we have been learning in class, not just like the lesson before, even that module, but like from kindergarten up, right? Like which is one of our standards, is being able to apply what we learn to the real world. So, and you would have to do in these stories the things that you would do in other stories, which is like predict, look for clues, figure out, what did the author mean when they say that? What does this character really want? You know, all the things that we do in language arts, but applying it in a math context. So absolutely, I think things like this could be integrated into language arts. Teachers and society in general thinks of math as like, this is math and this is language arts and this is science, and like they're all these separate things, when in fact math by itself is useless. I mean, not useless, but it really, like, its applications are in a whole bunch of other content areas. That's what makes math so exciting. So
you're looking at your little kids and looking at the video, they can begin to analyze and evaluate the information. You know, and they began to play with the buttons. You know, they were not afraid of the buttons anymore. Pencil and paper, they would be afraid of it. You justify and support your ideas. Why? You can say why. You can give the context, and you can generate new questions. You want them to be able to generate new questions. And that is how we have deep understanding. And we don't teach math that way. We want math as question and answer, yes and no, right and wrong. And that's not how it is. And we have to get away from that concept. You know, when you know something, you can recognize different points of view. And going back to that little girl, that she has 7 and 3 buttons. Another person had 6 and 4 buttons. A different point of view, but it's still 10. It's still 10. So, and then, you know, you can empathize with others. Oh, you have 6 and 4, and I have 7 and 3. We both have it, but we just did it differently. It's how we teach it. And that is why I'm excited by your work. You're beginning with the young ones, but I want to see the work continue with the older ones. It's how we teach it that is the problem. Math is not the problem. It's how we teach it.
How should we teach it?
We should teach it like you're doing it.
Should you like these books?
Yeah.
How come?
Because it's fun.
What's fun?
Math.
What did you learn?
Well, we're gonna get another now that with triangle you could do like make dog, bunny, cat, dog, and bird.
Did you know that before?
Yeah. This is our new book. Why did we not finish the old book?
You did.
But we didn't finish this one. No, we didn't finish the other one. The one we had from Miss Lunsford.
You did. You didn't?
We didn't get to do all the shirts.
Oh, you're gonna take it home.
I want to take that other one home and do the last shirt.
Okay.
I already did my side.